the University of Texas in Arlington, an aircraft with a strange mission is revving up. Today, pilot Steve Spence plans to fly the vehicle using a radio-controlled joystick. But it's just a test, because eventually this vehicle will have to lift off and hover on its own as a flying robot. It will compete with robots from other schools in the first ever aerial robotics contest. To qualify, computers, not man, will have to control the machine. For the contest, a sand volleyball court will be covered by a rubber mat and the net replaced by a 3-foot-tall barrier. On one end will be a source ring containing 6 neon orange discs. The object? A flying robot must pick up one disc at a time and bring it over to a target ring on the other side of the barrier. The contest is the brainchild of Georgia Tech professor Rob Mickelson.
One of the tasks that has to be performed is to locate these discs. The vehicles will have to fly over the ring in which these discs are contained and then look down or feel around to find the disc.
Back in Texas, they're testing a small search camera attached to the bottom of the robot.
Okay, David, bring it in.
The camera sends its picture to a computer.
Okay, slowly now. Okay, track 1.
When the faint white lines cross, the computer has recognized a disc. Now, the robot has to pick it up.
These discs have been designed so that they can be picked up with a suction device, some sort of tactile grabbing device, or they can be picked up magnetically.
A pulley draws the magnet and disc up to the base of the vehicle, where they sit until the robot navigates its way to the target ring.
Navigating may be one of the easier tasks that has to be done because the teams are allowed to set up navigation devices around the arena.
Texas is sending sonar signals to a receiver that will eventually go on the robot.
Okay, stop. Okay, go back towards the center.
Signals are sent out by 6 sonar beacons. As the vehicle moves, the distance each signal travels will change. An onboard computer calculates position based on the changing distances and tells the robot where to go next.
Okay, stop. Now do the rotate.
Sonar is nothing new. The hard part is programming the robot's onboard computer. It has to interpret the navigation data and control everything else the robot does. And because it's a contest, the work goes on in secret.
Some of the schools are probably doing things that are totally different than what we're thinking about, and it gets your adrenaline going.
In San Luis Obispo, Cal Poly is building a hovercraft.
Okay, well, as you can see here, we're running on a Briggs & Stratton 3.5 horsepower motor. It's just turning this plastic fan blade. It's much like a standard lawnmower would do.
It even starts like a lawnmower. It qualifies as a flying machine because it's not touching the ground. 2 more fans give the hovercraft a surprising amount of thrust. The hovercraft is speedy and stable, but it can't fly over a ring. The team plans to throw in a claw to pluck out the discs. The claw is part of a 5-foot-tall arm they're attaching to the top of the robot. The discs won't have to be located by a complicated camera system. The arm will just feel them. As it sweeps around the ring, it catches all the discs. But that's a problem.
The rules state clearly that you can only carry one of these discs at a time.
So a flap will close when the first disc gets caught. Since the other discs won't be locked in place, they should fall out when the arm lifts up. But it's not easy to teach the computer.
Yeah,
I didn't want to design something that everybody would finish with an A+. I wanted it to be a challenge. Therefore, it's a very difficult contest. I don't believe it's impossible. I don't know that everybody will be able to move all 6 discs. In fact, I doubt that any of the teams will move all 6 discs.
And now, the day of reckoning.
Ladies and gentlemen, welcome to the first International Aerial Robotics Competition, sponsored by the...
4 teams have entered. The judge briefs the first team up, the University of Dayton from Ohio.
And you tell me when you're ready to start, and that's when we'll start the clock for the 3 minutes.
They entered late and haven't had time for a test flight. Their passenger sits in on the maiden voyage. The vehicle is a helicopter, run on gasoline, and controlled by computer. Or not controlled, as it turns out. At least the passenger survives.
We're still intact.
Mechanical problems will happen. The world's not perfect. We just didn't have it balanced out quite well enough, and the computer couldn't control it.
I'd like my whole team to come up here, please.
Next, the hometown team, Georgia Tech, has a sad announcement.
We've been working almost night and day for the last 3 or 4 months, and as of 4:30 this morning had an engine failure that we just couldn't recover from. So we're sorry to say that we won't be able to show you anything, at least inside the arena. But feel free, please, to come back and ask us questions about our aircraft, because we're terribly proud of it.
The unwieldy hovercraft is brought in by Cal Poly team members. The judge looks on as the craft makes its way right to the ring and keeps going. The navigation system is out of order, so the team's out of the contest. But to demonstrate what it can do, they push the craft back. Some changes are made with laptop computer in hand, and the claw descends into the ring by itself. It sweeps over the bottom, feeling all 6 discs. And only 1 disc is lifted out. The robot's arm works perfectly.
We did pretty well. The control system works, and the arms works. It's just a little bit more fiddling with it, and we'll probably have a working system.
Next up, Texas.
When you have to let your baby go, it's like parents kicking their kids out the house. It's gone. It's all on its own now.
Sonar beacons on the fence. The receiver on board. Now it's all up to the computer. Steve carries the remote control joystick box out of the arena. He's only allowed to use it as a safety, to stop the robot if it accidentally flies outside the contest area. In its rather short flight, the Texas robot actually accomplished a lot.
It went directly towards the ring, didn't it? And it got off the ground, which is a great accomplishment.
As soon as the robot took off, it headed directly to the ring. The navigation computer calculated the correct position. But as the aircraft moved in to hover and search for the discs, the landing gear, enlarged at the last minute, hit the edge of the ring. The computer couldn't correct the balance in time. Still, at an almost impossible task, it was an impressive attempt.
I think it's evident that the University of Texas at Austin was the Arlington was the defined winner.
The Texas team has taken a first small step in aerial robotics. There's high hope for the future. But as for the present, one team insists they hold the best current technology for the job.
Well, I guess I just can't take the man out of the machine.
Flying robots are usually the stuff of Saturday morning cartoons. But some college engineering students are trying to build real robots that can perform airborne maneuvers. They usually play volleyball on this court. But instead, they played with robots. The Association for Unmanned Vehicle Systems turned the court into an arena for robots designed to fly. Engineering and science students from 5 universities entered their computerized projects, hoping to demonstrate good science and to win a $10,000 prize.
This is a way to get students interested in unmanned systems and to be able to apply what they're learning in schools.
The rules called for universities and industry to cooperate in creation and design. The results amount to off-the-shelf technology and some wishful thinking.
A lot of people doubted we could even make it this far, so this is a big accomplishment for us. We're not really competing against the other teams, we're competing against ourselves.
But all the competitors faced a tough challenge. That is, robots must retrieve 6 orange discs from a round ring, carry each of them over a wall, and drop them into another ring. And each robot must be autonomous, able to function on its own without any human help. Guidance systems relied on either lasers or ultrasound.
So they get 1, 2, 3, 4, and they'll send out an ultrasound signal. And what we use that signal to correlate our position on the arena. It gives us an XY coordinate.
The UT Arlington robot packs microchip sensors that are programmed to recognize the orange disc and a magnet to pick each one up. They called their entry the right half plane. Right half plane is an engineering term for something out of control. California Polytech had trouble controlling its hovercraft. It got to the ring, picked up the disc, but the technology demonstrated here may appear crude and unworkable, yet a similar type of flying unmanned vehicle has already proven itself in the war in the Gulf. These images were relayed by Pioneer, a flying robot that helped pinpoint Iraqi bombing targets. In this case, the Pioneer was controlled by radio from sailors on a battleship. But designers think future autonomous robots could help spot forest fires or hunt for leaks along oil pipelines.
You're working on something that you know that there's going to be a solution in the next 25 years, and you're wondering whether maybe something that you come up with will be the kinds of solutions that people will use in the future.
But from here, the future seemed far away. All 5 schools wound up sharing the prize money because nobody could get their robots to work as planned. For now, some Georgia Tech students proved people can still outdo robots. Well, there'll be another contest next year. Another chance for the student inventors to see if their ideas will fly.
The objective is to move some discs from a ring on one side of an arena over a barrier to the other side. But the real trick is not so much the moving them, it's that these unmanned vehicles are fully autonomous, and they've got to be able to perceive their environment, find the discs on their own without any human help, acquire them, pick them up, and then take them to this other location, which requires navigation. And that's the most significant part of the task that the teams have. In last year's competition, we had some helicopters that tipped over and the blades just went to pieces. This year, we haven't seen that. This year, the team seemed to have learned the stability questions a little bit better and have answered them such that the vehicles are at least staying straight level. Navigation seems to be a bit of a more of a problem this year. Acquiring a disc could happen this year. Taking it over to the other bin and coming back, I don't know. But we'll continue the challenge until someone is able to achieve the task. And when that occurs, then that'll be a milestone in technology, because it'll be doing something that's never been done before. Even the U.S. government has no vehicle now that can perform the particular task that we're trying to do here today.
Test in which engineering students from a dozen colleges and universities tried to design and build a flying robot capable of performing a task on its own without a human at the controls. Well, now we've asked Ted to open his reporter's notebook once more to let us see how the team featured in his first report has progressed. And weather permitting, he'll take us to the contest finals.
A dark, stormy June morning in Atlanta. Not a good day to test fly an experimental helicopter. Mark Gordon and other members of his team are stuck in the lab, working on various parts of this year's entry in the autonomous unmanned flying vehicle competition. The countdown is on. Just 16 days until these students compete against 14 other teams to see whose entry can fly in, pick up metal discs from a bin, and move them to another bin 10 yards away, all without human help. Tech team number 1 has been working for 6 months, and there's still a lot to do.
Things are real easy to just talk about, and then when you go to design it, that's when you really have to work hard.
Last year, the host, Georgia Tech, was earthbound, mechanical failure. Actually, no one's flying machine completed the task, although the University of Texas came close. So now the work in the lab is intense.
Late last night, early this morning, I decided I would just go ahead and change the state machine.
The plan? Take a helicopter model and modify it. Add a second robot to capture the disc.
When it finds a disc, it will signal the chopper that it has achieved one of the targets.
The time is running short to make it work.
Okay, at this point, it has sensed the presence of a disc. The chopper will lift the car off the ground.
For most of the students, this is their first experience working on a complex problem with engineers in fields other than their own.
It's one of these practical projects, real-world projects where you actually learn how to work with other people and you're working towards some goal.
Computer, electrical, mechanical, and aerospace engineers. Each has something to add in solving problems faced by the team. The group is confident, maybe even a little cocky.
I think that we'll do well this year.
Sunday night, finally clear skies. The team now has a video camera to record test flights, some with fairly hard landings. An overcast, muggy Monday afternoon. Flight testing continues. The pilot's a volunteer from a local model flying club. At this stage, he's still at the controls. One by one, systems are being transferred from him to the computer program that must fly the machine in the contest. This time, it's the altimeter. Later today, the visual system will be added and tested. Without it, the computer won't know where the chopper should go. But right now, there are problems with the altimeter. Each time the machine reaches about 2 feet, it begins to bounce, just a little. The team must decide if this is a major problem. Time to fire it up and try again. Suddenly, there's a bigger problem. A near crash, saved only by the skill of the human pilot. This time, the computer takes the blame.
I'm writing the flight control software. Yeah, that's what just screwed up and almost cost us a helicopter.
Today's test is over. The helicopter goes back into the lab. Ahead, more work with screwdrivers and voltage meters. More checking and rechecking. Flight testing the visual systems will have to wait. But confidence is still the watchword.
Maybe it doesn't look like much is going on. There's a lot getting done. The stuff is functioning. We're just finding, maybe a little glitch here, a little glitch there. This is functioning like a champ.
It was really close. That's the closest we've come to a crash this year, which is good. Last year we crashed every day. We have a pretty good system this year.
But will it be good enough? Friday morning, Partly cloudy, hot, humid. The time has come. Start your engines. Next year, the competition will be held at Oakland University in Detroit, Michigan. And the rules will require the vehicles to roll to the target, not fly. Next year's competition will be for ground vehicles. Ted Texter, CNN Future Watch.
Once again, it's time for us to fly. For all of us on Future Watch, I'm Donna Kelly.